So our webinar today, clear audio for debating chambers, processing, distribution and control. This is a webinar on our PBS system, Parliamentary Broadcast System, and debating chamber system and committee rooms, sorry. This is what we're going to talk about, and specifically focusing on the front core functions of PBS and the principles of clarity, what's involved in achieving clarity. And then an overview of the component elements of PBS, because it's been introduced to people quite late, even though we've been doing it a long while. We can give you an overview of the system so you can probably better understand yourself how the core parts of it go together and how it may be used. This is not going to go into any one area in any great detail. This is an overview, and we can do great detail separately another time if we need to get into that. So there's our greatest AI generated generic debating chamber to introduce our PBS system. So what is it? It's a combination of hardware and software systems that we've been finely tuning over 30 years now, that is specifically designed for solving the audio requirements of debating chambers and committee rooms that are very, very unique. They're not standard environments. So PBS has been tailored specifically for these environments. It's used at the moment in some of the largest and most impressive parliamentary buildings in the world. It's been very widely tested over the last 30 years with a stepwise refinement as we've gone through to tackle all the problems that's encountered in these environments. Most recently at the Scottish Parliament in the UK, which arguably holds the title of the most advanced and capable parliamentary AV system currently in use around the world. Our audio part is only a part of that. The entire package that they've put together in Scotland, their whole AV system, is absolutely fantastic. They've done an amazing job there. And I know some people here watching today have seen the system, and it really is a fantastic system they have at the Scottish Parliament, the audio side of which is our PBS. So the three functions of the Parliamentary Broadcast System: processing, the front end processing, the ingesting of the microphone audio and the connection of the output speakers. Processing of this audio for the sole purpose of maintaining and increasing clarity in the chamber using delay techniques, EQ and frequency shifting. That is fundamental. We're gathering the audio information and sharing it out in the cleanest, clearest way that we can. The PBS system also distributes the audio. It's the management for any of the given purposes that any parliament would need it for. We produce the clean feeds, different mixes as required within the chambers, the local mixes required, or as part of remote contribution connections, and all the outputs that are required for the main transmission paths, such as broadcast, streaming, logging, and transcribing. So whatever the various outputs, mix combinations required, the distribution of audio is all managed by PBS. And finally, the control of the system, not just the control of PBS itself, but control of the various parts of PBS as well, the various connected user groups within PBS. We can create profiles for control so that any given user type, if they're more of an admin role, if they're the chair of a meeting or the speaker in a debating chamber, we can provide them with control screens that just give them the information and control that they need for their specific job and nothing else, to make it as simple and directly controllable as possible. PBS will automate repetitive functions. This increases the process of a debate for to aid with the speed and flow, because there's no waiting. Historically, bits of paper are passed around for running orders and notes going between people. It automates all that process and speeds it up. This can be via software screens or indeed direct hardware panels or combinations of both. It doesn't just have to be software screens. And of course, for control, we manage all the microphones and loudspeakers in each environment for maintaining the clarity within the chamber. Now, I've mentioned clarity a few times already, because clarity really is the key point of the entire system. These are very important environments that PBS is used in, and clarity is absolutely paramount. I'll put here that it's often taken for granted. Any system that you'd look at, they would claim that it's clear. So what we're hoping to demonstrate here is what PBS does to actually obtain clarity. And we're not just saying it, we're demonstrating that we can obtain the maximum clarity level in any given room, because clarity is everything. Because when it's clear, you don't have to try to listen to it. You can just hear it. It makes it less fatiguing. Political debates can be many, many hours, long sessions, and it becomes fatiguing. If you're trying hard to listen, it's more fatiguing. If you don't have to try to listen, you can just hear it. It's a much more pleasant debate. So the primary goal of Glensound PBS is clarity. Clarity is what we're all about. It's also important on a world scale, because we're talking about world governments here and national debating chambers. Significant issues are discussed and debated. It could be announcing a war, a vote on Brexit, or introducing a tariff, who knows. So government debating chambers must have clarity in the chamber themselves, so the attendees in the chamber can clearly hear, and for the broadcast channels, so the rest of the world can hear. Very, very important that we maintain that clarity. Within these debating chambers, there are many significant challenges. Government debating chambers are very large rooms. Sometimes you can have up to 500 MPs or more. There are hard surfaces, lots of opportunities for reflections and reverberation around the room on the hard surfaces, so it's quite an unforgiving environment. There could be 300 microphones or more, all picking up audio potentially in some systems, creating lots of incoming audio streams. MPs are not expert at using microphones, so their poor microphone technique can cause further problems. And within any room, there could be 500 separate speakers, all different sound sources, all adding audio and reverberations within the room. It's a very, very daunting environment in which to make sure everyone in the room, 500 MPs in a room, can all hear clearly themselves, and all of the audio being distributed to broadcast is also clear. So these are the problems that we are trying to solve with our PBS system. So how do we do this? First thing we do is we want to know the exact position of every speaker and every microphone in the room. So we want the X and Y position of every speaker and every microphone. When we know the physical locations, we can then start working out delay profiles. But we need to start with fixed locations for those microphones and loudspeakers in the room, whether they're the desk-mounted speakers, they're infill speakers along the side, in galleries where the different microphones are. We need to know the physical position of every device. We then take measurements from every microphone to get the delay to each individual loudspeaker in the room. So if we've got 300 mics and 500 speakers, every mic we need to know the delay to all of the 500 speakers in the room. We might not use them all, but we start by knowing the information, because that allows us to then work on the delay profiling. So we need those measurements of delay from the microphones to every speaker. Based on the particular requirements of any given project, we then produce delay bands or individually delay per speaker, if that's required, from every mic. It's typically bands, a radius radiating out from every active microphone. But again, the system is tailored to whatever the particular requirements of the project are, and we will respond to that. But the basic concept is we will have individual delay or delay bands from every microphone to the speaker, each speaker. We then have the profile for the room, which changes dynamically based on the active microphone. So in the main debating chambers, these are typically manually switched, and every time an active microphone is switched, the delay to every speaker or group of speakers is changing dynamically all the time as we're switching microphones. So there's a lot of processing going on to manage the delay between the multiple incoming mics and source speakers for us to maintain and minimize all of the delay within the chamber. Very significant part of the system. What you're looking at here, I'm going to mention this later. These are some of the speaker pods that we have for a disaster recovery system, but we'll talk about that a bit later on. We then perform some speaker dimming and muting. Quite straightforward that the speakers nearest an active mic are muted, and the speakers at the next preset level away from the active mic are dimmed. The exact configuration of these is variable on commissioning, and this helps prevent the direct source of any potential feedback, without affecting clarity, because the people in the immediate vicinity will be able to hear regardless. When we have the delay profile in place, we can do A/B comparisons of a chamber with the delay processing on and the delay processing off. And it's always quite interesting that when you hear the room, the chamber, with the delay off, it can still sound very clear. And most people are impressed with the clarity of the sound. And then you turn the delay processing on, and there's a snapping effect of everything just tightening, coming into focus, where a layer of muddiness disappears that you weren't even aware of, and it all of a sudden becomes a much clearer system, a much brighter and clearer system. So our PBS system has got the amount of DSP horsepower available to be able to process the high number of mic channels that are typically required to provide this significant audio enhancement that removes the coloration that multiple audio sources create, all the reverberations within a room of which we're all familiar with in these challenging environments. So the amount of DSP and processing that we have with our audio delays largely removes this and dramatically increases the clarity in that given room. Equalization and filtering. Setting an EQ profile sounds quite straightforward, but it's not as straightforward as it sounds at all. This is a very specialist process and an important step to provide the correct equalization using a proper acoustician to make sure we achieve the ultimate clarity in the particular chamber. A pseudo-random source is generated, and we create the measurements with the measurement microphone to record multiple sample speakers across the room. This varies depending on the size and the locations, but there's a generic sample taken across the room, and we take this sample response from each speaker and enter this into the DSP of the PBS system. Our acoustician would then interpret this to identify key factors, the measurement artifacts, the resonance within the room, and the speaker response. And this is what allows us to set optimal EQ settings for clarity in the room. Another process for achieving greater clarity is we use notch filters. In the empty chamber, we take the gain up to the point of almost feedback where you can just start to hear it ring. When it's just starting to ring, you can identify these frequencies and add notch filters within the key frequencies where feedback is most likely. So we remove those most sensitive areas with notch filters and making sure that we maintain the intelligibility and clarity as we're doing that to make sure that we're really neutralizing those problem frequency areas within the room. And finally, with the room equalized and filtered and still under the point of feedback at this point, we then add our frequency shifter, which has been refined over many, many years. This was designed initially for one of the early Parliament systems that we had. And as a frequency shifter, it's constantly monitoring the audio. And if it starts a loop, a feedback loop, it just moves the frequency by 5 Hertz every time it loops, which dramatically removes the chance of any significant feedback occurring. And remember, we're doing this at the moment still below the point of feedback in the room in an empty chamber, which is the worst case scenario for any potential feedback that might occur. We now have the maximum gain level for the system, and that can be set as the maximum because the control of the system is automatic. Nobody's controlling mic levels during a debate. PBS is managing that. So we now have an overall maximum level available that the operators can run up to. Typically, this is quite a high level, louder than they would need, because we're now able to create volume if it's required with clear audio. So if we're turning up the level, we're turning up clear audio. We're not turning up bad audio. So the need for high level is actually reduced, because if you can hear it clearly, there's less of an inclination just to make it louder. So we typically have plenty of volume available if it's ever required, and we have the ceiling of operation for the system that will not be approaching any feedback issues, because we've already notch filtered out the problem areas. We've got a frequency shifter. The room is EQ'd. We put the profile of the room together without making any of the compromises on the clarity in the room. So that's the processes that we've put in place: the dynamic delay, the equalization, the filtering, the frequency shifting, and the speaker dimming and muting, all combining together for the properly measured and set room that will perform at maximum clarity without any feedback issues. Clarity plus level. So that's the clarity part of the system. Well, I thought it was worth emphasizing, because that is really what it's all about. And that's if we don't have that, then everything else is irrelevant. What I want to do now is show you the key component areas to give you an idea of how a system might go together. We're not going to look at any one in any detail, but it'll just give you an idea of an overview of the PBS system, so that if you're thinking of the system for a project, you'll have a better understanding of how it goes together. These are the master controllers. We have two master controllers at the moment. I say at the moment because obviously we have a core system within PBS. But every time we have a project or a parliament, this tends to evolve because this is a building block system that's typically added to meet the requirements of any given parliament that we go to. So take what we're saying here as a guide. This is where we're at the moment, but that doesn't mean that's how it is. That just means that's where we are at the moment. So at the moment we have a 32 channel master and a 116 channel master, which start as the base units for controlling of the system. The PBS whip, these are the additional DSP cards. So as we add microphones and we require further DSP, then we add PBS whips to manage the number of channels as they increase. So this is a 4-card rack, which we can populate with 1, 2, or 3 or 4 cards as is required. And each rack fully populated can add another 128 delegates in the room on top of the provision that the master controller DSP has. So these are the mic amps, the preamps and interfaces for ingesting some boundary microphones, gallery microphones, because every desk position, if you have desk positions, there are mic amps as part of the desk position units. So these are really the auxiliary ones that are not on the MP's desks directly, and the general I/O units for the analog or digital distribution to external sources, broadcast, etc. These are the amplifiers. Again, the desk units for each MP have the amplifiers in for the individual speakers in front of every MP. So these are the loudspeakers that are not part of that unit. So if there's a parliament, we have some in the UK where there are not desk positions and the speakers are in the chairs behind you. So therefore we have multiple loudspeakers that we have to drive directly with multiple channels of loudspeaker amplifiers. There can be gallery speakers, and any other general speakers throughout the room that are not part of the desk setup for the MP. These are the amplifiers that we would put in for controlling or providing the amplification to those. PBS is a Dante system. It's a Dante network audio system. With redundancy available as standard, there are primary and secondary network redundancy as standard within the system. But we can also have a complete redundant system, which is effectively a duplication of the entire back end with our PBS deputy, the main reserve switcher, put between the two, and the CR Vice there, which is this little push button. Because all of the parliaments that we've provided for at the moment all do manual switching between main and reserve. Maybe there's a place for auto switching, could be looked at if ever required, but the parliaments at the moment have always wanted to manually switch if they were to go to the full reserve system. So these are the devices that take care of the switching between the main and reserve system. If you have that option, not a requirement, it is an option on the PBS system if you want full system redundancy. The PBS MI5, this is a privacy unit. This was the original unit that became the Glensound Victoria, if you were interested. So this is a network isolation bridge where it also isolates the audio network used within the Parliament chamber from the rest of the audio network that connects to the outside world. So it means that we can pass audio between Parliament, between broadcast and other users within the wider network, but there is no data connection. The audio is passed in DSP. There's no data connection, so it's an isolated network, which reduces any of the configuration or primarily the security aspects of having a Parliament network open to the outside world. With the MI5, the Parliament network is isolated and it is not part of a network that is open to the outside world. So this is quite a common unit that would be specified. So we're onto the desktop panels here. In a modern Parliament, they're normally seated with a desk unit in front of them. There are many options of panels here with mics, buttons, card readers in different combinations. Often, or more often than not, they are connecting into existing furniture in the chamber. So whether that's historical furniture that we have to make sure that we cater for. I know there are certainly parliaments within the UK where we have to take screws out of existing units and use the same screws, putting units back in. So whatever the requirements of the Parliament are, if we have to match colours with the panel work, if we have to match certain shapes within the panelling, we can make sure that we achieve that within whatever the requirement of the Parliament is. At the top and on the right, these are furniture mounted panels, which are fairly typical. On the bottom right there, you can see we have a gooseneck microphone, which is on a damped connector to avoid any bangs and knocks being transferred into the mic stem. We have a mini jack headphone there and a 4-input switcher that is typically used for interpreted audio. If any non-local language audio is happening and as an interpreter, the MP can switch between audio sources for monitoring that. Then on the bottom left, the other buttons are typically used for voting. We've got a yes, no, abstain, and then the bottom row there, request to speak, interrupt, or point of order, which are very common parliamentary process buttons used during a debate. These are all coloured switches. How they light, whether they flash, the process of what they do can all be configured as part of the system commissioning. If you want certain or multiple lights to come on to indicate their mic is live, we have parliaments that use an Audio-Technica gooseneck mic where they have a ring light on the mic itself and that illuminates. We turn that on when the mic is live to indicate it's live. A project we're doing at the moment is having an LED on the top panel of the base unit, so you'll be able to see functions. I believe they're using it for the mic switching that will be on the top because they've required an LED on the top panel that we can do that. The bottom left here is a freestanding unit for the applications where it's not in furniture, and if you need a freestanding unit, the operation is the same. On the bottom right picture, actually to the left, you see the more utility functions. There we have a 3-pin UK socket and an RJ45, so you've got power and network there. More common now is to put a power socket with some USB connections, USB-Cs or whatever's required, so the MPs can just charge their phones while they're sitting at the desk. These sort of utility functions. It's whatever's required for the specific project that we will look at. That bottom right picture as well on the right side is also showing the card reader slot. Many parliaments now like to know who's sitting at what seat, and then we can make sure that it all interfaces with the system when we know which MP is there. Their pictures can come up on the screens when they're talking. Their ID is logged when their mic is active, so we can reference them in the recording that their mic was live, so we know it was them. And of course, we can log any voting that happens through the yes, no abstain buttons. That's an optional part. If you wish to add the reader, it can be added retrospectively if required, but it gives you an idea of the top end options that are available to the MPs. These all connect to an under desk module, which is one of these. These are the MOPs. We have a MOP 1, which is an interface for a single MP, which gives you a mic amp, a loudspeaker amp, a headphone amp, and some DSP for processing. This connects up to the desk unit on the top. They act as a pair. There's also a MOP 4, which is very similar, but for 4 MP connections. The MOP 4 is typically used in committee rooms rather than a MOP 1, but they both do the same job. It's just whether you want a single input interface or a 4 input interface. But you can see there we've got wings on the side, and it can screw up under a desk or on the side internally out of view with your network connections and all the links up to the unit on the top side of the desk. Now these are the operator panels, which are customized hardware panels that mirror the layout of the room. So they're all unique because they all refer to the room in which they're used. So the first one we have here, the PBS SPK, this is an operator panel for a main debating chamber, and typically the mic switching you would have here. Each of these buttons is a mic switch on and off. On the left side, you may have the opposition. On the right side, you'd have the government. It's just a palm rest in the middle, and it's manually switching of microphones just on top of the palm rest there. That's where you would have the Prime Minister and the leader of the opposition at their dispatch boxes talking. And this is the control panel for the mic. On the left side there is a fader. That's the overall volume fader with some auxiliary functions on the top of the panel. So that's a main debating chamber hardware panel. This is an example of a committee room panel. You can see the typical shape there at the bottom of a committee room layout. Typically, committee room control panels have some more auxiliary functions. The buttons under the fader and under the top section there, they're often used for PTZ camera switching, where we'd use this panel directly for PTZ camera switching. But this you can set in an automatic mode. It can be a manual switching mode. There's systems on here for controlling the radio microphones and whether you're having outside sources coming in. So this would be typically Zoom calls, the remote contribution calls, and a bit of metering there. The exact profile can be changed. Again, it's a custom panel that's defined as per the requirements of each given project. This is a very interesting little panel, the CR Attend. So this is for self-op committee rooms. Because when you have smaller committee rooms, there is no need for an engineer or operator to be present. The chair simply turns the system on and off. Turning the system on starts recording. It starts all the dynamic processing of the microphones. It starts all the dynamic processing of the loudspeakers. They can control the volume up and down. We know they're not going to turn it up too loud to cause any feedback problems because the room's been preset. And they can just decide whether they're having a private or public meeting, whether the the remote contributions Hansard is logging, hearing loop system is active. There's just a few simple settings there that can be enabled. And when they finish, they just hit power off. That puts the end stamp on the recording. Everything is logged and they walk away. It's a very simple self-op control panel. Obviously our DSP is doing all the work, but this is just a remote control to enable it. Really makes it very straightforward for managing committee rooms, because in any given parliament, In England, for example, we have two main debating chambers, House of Commons and House of Lords, but there are about 30 committee rooms in England. So there are always, in any given parliament, multiple committee rooms. And the PBS is the same core system for committee rooms and the debating chambers. It's just a case of the slightly different front ends to it and how we control it. So now we're into the software, which for a lot of people is perhaps the more interesting side, the Busby software that's designed for the control of the system. Not only does it control our system, but it interfaces with all the key stakeholder partners that would be involved in any parliament, but from the entire audio-visual spectrum. So typically, Busby would be interfacing with the logging software. A lot of people use Slick. It's quite a common one in parliamentary use. We can do the logging within Busby ourselves as well, if required. We control the cameras, so all the PTZ cameras. So when mics are live, we're telling the cameras where to point and making sure they're pointing at the right MP. The Busby system is also controlling the on-screen graphics. So if a certain MP goes on, the camera points to them, and then we put the graphics across the bottom of the screen, the MP's name, what party they're from, etc., etc. We can integrate with the vision mixers. And thanks to COVID, we have a very sophisticated Zoom integration within PBS and Busby. That means we can interface with MPs working at home on Zoom, where the PBS system, Busby, is controlling the microphone and levels of that remote MP. And not only that, but the 6 key buttons for parliamentary process that we looked at, which are the 3 voting buttons, yes, no, abstain, and the 3 parliamentary process buttons of interrupt, request to speak, and point of order, they are superimposed on the screen that will allow that politician to take part in the debate from home exactly the same as if he was in the chamber. We produce all the correct clean feeds for him, process his audio coming in and distribute it to the right places. And it's a really nice, seamless integration to a point where I know there are some parliaments that happily work in a hybrid mode where MPs can readily work from home if they wish or come into the main chamber, because in terms of parliamentary process, it really doesn't make any difference whether they're at home or in the chamber, because they can still take part. So Busby is integral in controlling the core PBS hardware and interfacing with the other parties involved in the AV system of a parliament. During the configuration, the order of business is added. You can set timers and prompts to that need to be set to or adhered to. We can also set prompts for individual MPs' mics if they need to keep to uniform times for speaking. Whatever really the rules of any given parliament, we can adapt the timers and set up to accommodate and work with that. The process for starting debate has been very much simplified and automated. It's a very simple process, even automatically sending out emails to MPs that are required to attend when a debate or a chamber process is scheduled and put together. When a debate starts, all of the functions that are required all start automatically. Logging starts, there are timestamps, the records of who's speaking and when. This is all logged, recorded for simple recall of audio clips in the future, all correctly ID'd. And we also create automatically a transcription of the process, the debate as well, if people would refer to check against a transcripted record rather than an audio record. It's a core set of modules within Busby. but again, they are tailored to meet the specific requirements because of the different types of operators that you would have in a parliament, typically of which there are three or four. Their screen will just be tailored to provide just the information that they need, as I mentioned earlier. Um, so the operators really like it because they don't have any clutter. It's just the information that they need right in front of them, and nothing else. So it's a much simpler, easy process for every individual user of the system. Um, Typically, we've been working with many parliaments from the start for 30 years. And as systems evolve, the PBS and Busby systems will evolve with them as different functions are added for different rooms. They need to expand, they need to change how things work. It's an ongoing partnership. We're always part um, of the system. We never walk away because we're always being asked questions. Can we check this? Can we do this? Can we add this? We're always around, and these systems evolve. They're constantly evolving from the first one that we've worked on that we're still involved with. I'm being a bit cautious because we can't mention names. You've probably worked out some of them, but we're not particularly allowed to talk about it. But it's an evolving system. Even as recently, the interpreters box that we had, that was a specific requirement for one of our parliaments that we designed an interpreters box for them for the project. So it's evolving all the time. So to look at the key screens, this is a key screen used by potentially the speaker or the person in charge of the chamber. They have different names in different places. This screen is indicating that they are using the ID card readers. So an MP can sit in any location, they can sit in any position. The screen puts their picture on the circle to indicate where they're sitting. We know who's sitting there now. We can see how the Parliament's laid out. We've got, we can't see any here, but there are coloured rings around each MP. And the operator of this screen, if they click on each person, that will just activate their microphone. And they will indicate down here to show that they are live. And some indication, visual indication on their desk will show that they are live, if that's required. As well, if they are on a request to speak or an intervention, we can have different colours on the outer rings to show that they are wishing to intervene. So the operator here, you see from a very clear, simple display, they're able to manage a typical debate, turn mics on and off, see who's wanting to speak and in what capacity, and they can control it all very simply. Just out of interest, we can have up to 4 active microphones. Obviously, the fewer mics we have, the better, but we can have up to 4 at a maximum without sort of overloading the delay profiles in the room and it's starting to significantly affect the clarity. Two is normal, 1 or 2 is normal, but we can go up to 4. Here we have another panel. On this one, we've got the MPs listed on the left side. The centre panel is showing the running order. So whatever the order of business is for the day will be shown in the centre. And then the 3 columns there showing the point of order, intervention and request to speak. They're shown as a ladder. So any of the MPs that have pressed the corresponding button, they'll be there in order of when they press their button, indicating that they are making the indicated request. This is the main operator screen here showing the timer. They can start and stop the debate from this screen, and where any specific timers that have been set are monitored from this screen. So this is one of the main ones for a clerk or an admin person to be using as part of the debating process. The screen on the left will also show, this is an offline screen at the moment, obviously, but the screen on the left will also show whether the MP is in the chamber or a remote contributor. So that's the general overview. We've got clear audio in the chamber. We offer reliability and redundancy with a primary and secondary Dante network and a complete redundant failover system option as well. We have a core modules of software and hardware bricks for the system that is customizable to apply to any individual Parliament's requirements. So we start as an off-the-shelf system and then we adapt to meet the specific requirements of any Parliament. We integrate with the other broadcast systems. We are not an island. We are audio specialists and we do our part, but then we make sure that our part integrates with everyone else's part as well. We allow the interfacing with the new technologies like Zoom for full remote control, remote contribution and hybrid operation in the chamber. The process of debates is sped up. There's less wasted time. There are more efficient debates happening as a result of using PBS, and a lot of those automatic repetitive tasks are automated, again reducing time and any delays in process. That was an overview of the elements of the system, just a very brief overview. As you can imagine, any one element of the system can take some time to go into. We can look further at other elements of the system if required. So a few examples. People often want to look a lot more into the Busby control software functions and the different options available with that. We can look at separate discussions and presentations for that. We didn't mention the committee rooms too much, but if you're thinking about committee room applications, we can certainly spend a bit more time with you looking at how we would cater specifically for committee rooms. And I showed you the speaker tubes at the start. That's our disaster recovery system. So if the worst should happen in any parliamentary building, that it becomes unusable, the function of government must continue. So we have a portable disaster recovery system that can be set up within a couple of days to be ready to go in a separate location. And if an overview of the disaster recovery system is relevant for you, we can look at how we have done that in the past. It's a very big system that there are many elements to, but they all come back to clarity at the end of the day. It's all about making the system clear and intelligible in the room and for the wider broadcast world, and accommodating all of the other stakeholders within the AV system of a parliamentary building. So that's me, that's my overview. I will look over to Ian now, because Ian Hayworth, I don't know if we've had any questions come in while I have been talking.
No, I think you've covered everything by the looks of it, because we haven't got any questions as it stands.
Everyone must be completely satisfied then and completely full of knowledge.
I can see the orders flowing in, but no, we keep an eye on that. Again, there was a couple of people that came in late. Again, not a problem, but if you did need a copy or to go through some other pieces at a later date, we can cover that if we need to.
Okay, if we hold on 1 second, Mr. Toshner is wishing to contribute here. Oh, I've got two Arnies on. Mr. Toshner, you are live.
So my question is this. Is Glensound going to come up with pricing for Glensound technicians to be on site at the location while this system is being installed and commissioned?
Yes, of course. Okay, yes, we have that information for commissioning. It varies per project because we often work with
Of course.
a system integrator and a main contractor, and our part may change, but we are typically around to do the final commissioning. Ian Burns, he's in a short time will be heading off to Canada to do some commissioning in Canada.
So my next question is, do you plan to generate some type of white paper for consultants and acousticians to understand the system and also understand what their part is in the commissioning of the system?
That is all possible if that is required. I wouldn't say it's on our job list at the moment in order to prepare that generically, but if you were to say to me, I kind of need a workflow for the different people involved and the acousticians of what their job is, then that is something we can do. Indeed, Ian Burns and I have a meeting tomorrow talking about that very topic with an acoustician.
Okay, in our particular case in North America, these type of systems are specified by consultants. And the more information we can give consultants on the system, the better chance we have of being specified. That's it.
Yeah, absolutely. Yeah, I think that's a good idea.
Okay, we finished.
Okay, thanks very much, Arnie. Did anyone else have any further questions? I think we are about there, aren't we? Okay, well, that just allows me to say at the end then, thank you for your time. I think you'll get an email at the end of this webinar that will have a link on there that will allow you to archive this webinar for colleagues to show other people. We will put it on our YouTube channel as well, so it will be available. And if you have any questions post the event, just to keep it easy, our generic email address is sales@glensound.com. You can send us any questions that you may have, and we'll look into that for you. You okay, Mr. H? Everything fine with you?
All good, thank you. Yep.
Yeah, okay.
Yep, lovely.
Well, I will just say thank you very much then, everyone. Thank you for your time, and I wish you a good day. Thank you for joining us. Have a good day.
Thank you all.
Yes.
Thanks.
Cheers. Bye-bye.
Bye-bye.
All right. Thanks. Bye.